Hello, this is Dr. Ted D'Amico, and today we'll be discussing the sixth media and marketing research fallacy, which is that data fusion provides accurate net reach estimates because it maintains the relationship among measures across studies. Before discussing the problems associated with data fusion, let's first discuss what this process entails. In most fusion approaches, the data from one study are combined with the data from a totally different study on a respondent by respondent basis. For example, the data from a TV study or website study may be combined with data from a general media and marketing study. The basis for combining these two studies is virtually identical to the approach used in wholesale ascription. That is, the data of a given person in one study are assigned to a person in the other study based primarily on the two people matching on certain key demographic measures, which in almost all instances are extremely poor predictors of consumer behavior. For example, people in a general media or marketing study are assigned the TV viewership of people in another study because they primarily match on sex, age, presence of children, and perhaps a few other demographic variables. Although other measures may be involved in the matching process, these measures are usually given little weight because key to this process is that the medium variables in the two studies, for example, magazine readership from one study and TV viewership from the other study, must be maintained in the fused database, both in total and by key age and sex breaks. Data fusion has two main purposes. The first is to examine the relationship between measures which are collected across different studies. For example, what percentage of people who watch a given TV program or network also own a dog? The second purpose, which is really an extension of the first, is to determine the net reach of two or more media vehicles. For example, what percent of readers of magazine X also visit magazine X's website within the past 30 days? Although these are noble purposes, fusion, like ascription, fails miserably when it comes to maintaining the relationship of measures that are strongly correlated. For example, reading a magazine and going to the magazine's website. This is primarily due to the fact that, like wholesale ascription, the demographic variables that are primarily used to match respondents are almost always terrible predictors of consumer behavior. Moreover, and more importantly, unlike wholesale ascription, with fusion, 100% of the data are made up. That is, they are totally ascribed. And there are generally many less variables to match respondents across the two data sources. Thus, fusion is nothing more than 100% wholesale ascription, with the further limitation that respondents are more difficult to match because the two studies that are combined have a limited number of variables in common. As a consequence of these two differences, fusion is almost always going to seriously distort the interrelationship among measures that are collected in different studies if the measures are strongly correlated. In the case of media measures, this means that if measures are strongly correlated, for example, reading golf publications and watching TV golf tournaments, the unduplicated net reach estimate will almost always be grossly overstated. The following hypothetical example is provided to further illustrate the problems associated with fusion. For argument's sake, let's assume that among magazine X's target audience in the past month, 50% read the magazine, 50% went to the magazine's website, and all of the readers of the magazine visited the magazine's website. Thus, the unduplicated net reach of the two properties is 50%, because everyone who reads magazine X also visits the magazine's website. However, if the readership and website measures came from two different databases, which were subsequently fused, the net reach estimate would be closer to 75%. The reason for this gross overestimation is because, like almost all fusions, demographic variables were the primary hooks used to fuse the two databases. Because demographic variables are extremely poor predictors of consumer behavior, the likelihood of a reader and a non-reader being fused with a website visitor is approximately the same. Thus, based on probability, half of the non-readers, or 25% of the total sample, would be fused with a website visitor. Now let's discuss various methods for estimating the distortion that can result from fusion. Often it is difficult to determine whether fusion distorts the relationship between any two measures, and if so, the degree of the distortion. However, one could easily assess the distortion if the two measures are collected in a single study among the same individuals. In this case, one would compare the overlap of the two measures within the database containing both measures with the overlap estimate based upon the fused database. When comparing the two overlap estimates, however, one should keep in mind that some of the difference between the two estimates may be due to differences in terms of sample composition, when the measures were collected, and the specific way in which the questions were asked. Another way of assessing whether fusion distorts the relationship between two measures is to determine how well one or both of the measures can be predicted on the basis of the hooks used in the fusion process. To illustrate, consider two databases which contain measures that are obviously related. One database has data regarding whether people read magazine X, and the other database has information regarding whether people visited the magazine's website in the past 30 days. If one cannot accurately predict either the readership or website measure by using the hooks used to fuse the two databases, one can be reasonably sure that the net reach between these two measures will be substantially overstated in the fused database.